Hey folks, just thought you might find this interesting. I opened up the actual Windows kernel inside of IDA Pro disassembler, and you could literally reverse the entire Windows kernel if you wanted to, because it opens up just fine. Um, Now this was the Windows XP Service Pack 3, so this is, old, but nevertheless, it's pretty cool that you can do this. You could actually do this for free because you can download IDA Pro free and just make sure you're using a 32-bit version of Windows XP. So this kernel file is massive. It's 2 point something megabytes, and it's just straight code. And as you can see here, there's something around 6,800 functions inside of this thing. And if you go to Wikipedia and you look up the name of the actual file, check this out. I found you can just type you can just go to Google and type in what is NTOS kernel like that as well. That'll work. Oops. No, you can delete results. So yeah, if you do that, you'll get to this Wikipedia page here, and basically the Wikipedia page tells you what I just said, that it has the cache manager, the executive, the kernel, the security reference monitor, the memory manager, and the scheduler. So this is all the low-level stuff that interfaces with the hardware, and like the CPU, the scheduler it has all the memory management and CPU management stuff. So now this table here, NT-function prefixes, will show you, it's like a legend for the different prefixes that we see in there. So it's neat because, so if you want to find the functions that are the real internal only kernel functions, you just look for the KI prefix. So that's what I was doing when I first pulled the screen up. I had the KIs up, so right here. So these aren't even exported at all. These are all internal kernel functions, like KI floating dispatch, KI find ready thread, KI find first set right bit. Um, that's what these all are here. And then we have the LPC, the LDR. So the LDR ones have to do with the loader, the Windows loader. Like you can see, enumerate resources, access resources. So they're talking about the resources in the portable executable file here. And then MI I haven't looked at yet. Let's check out what MI is. MI is memory management routines not exported for call outside the memory manager. Okay, so basically it's M internal. Or oops, I'm already there. So these are memory manager functions here. Create memory event, makes sense. Create image file map, create paging file map. So this is the stuff that's setting up the actual page, the memory pages and everything. So pretty cool stuff. It's absolutely massive, and there's no way one person would be able to reverse engineer this in any short period of time. But and it's interesting because some of these functions I actually have seen in ntdll.dll, which is the API that interfaces with kernel32.dll, which is the API that most developers and programmers interface with. I talked about that in another video. So, but this is massive on a whole nother level, because this is basically basically the meat and potatoes of the operating system right here. And then you can see here that there's exports, there's a lot less exports than there are total number of functions. So obviously those internal functions won't be on here because um, they're not exports. And even still though, I mean, we got 1,490 exports or something like that. So that's still plenty of exports here. Like these KEs here. There's a lot of KEs. Let's look what that says. Core kernel routines. So yeah, I mean, you can play around with this all you want, and it's pretty cool. You could actually, if you really wanted to see how how a particular function in the Windows operating system works, you could just double click it in IDA here and go check it out. Let's go look at one of those internal functions real quick. It's kind of sweet. How about ki ready thread? See, so you could go through this thing and just reverse engineer it and see what it's doing. Pretty cool. Now, another thing I want to bring up is that a lot of these internal functions are probably not documented at all. So, like if I search for ki ready thread, there's no official information from Microsoft at all about this. And you can see here that there's very limited information. Now this site actually has some info on this particular thing. It says thread is called when the current thread or the CPU. Let's see what this says here. How are threads assigned to cores? Is it a static assignment? Is there a notion of migration? Oh, here we go. The Windows scheduler has developed in a time where there was no notion of core, only of CPU. So ki find ready thread is called when the current thread on the CPU cannot run anymore due to termination or waiting on the event similar object. This function chooses the new thread for the CPU, and the CPU later switches to it. Ki ready thread is called when the new ready thread appears in the system due to thread creation or due to wait satisfaction. Well, so yeah, that's pretty interesting stuff right here. Credit Maxim Shotsky. So anyway, yeah, so you can screw around with this, but as you can see, there's very limited information, very limited official information on this stuff, because this is the actual internals of the closed source Windows operating system. All right, so thanks for watching. Thought you might find that kind of interesting. Go explore, see what you can find, and I'll talk to you later. Oh, by the way, do this at your own risk because I'm not sure if this is even technically allowed. So don't tell them I sent you.